Fine, let's start. Number 10. The plumes. Picture a spacecraft the size of a small car, falling silently past a frozen moon at thousands of kilometers an hour. It is 1997. The probe is called Galileo, and it is threading a close pass over Europa, one of the 4 big moons of Jupiter. It swings in to about 400 kilometers above the ice. That's closer than the distance from New York to Washington. And then it climbs away, back out into the radiation, and keeps going. Nobody on the team thinks anything unusual happened. The instruments recorded their numbers. The data got filed, and there it sat, for more than 20 years. Then, in 2018, a scientist named Jianji Jia at the University of Michigan pulled that old data back out. He had something the original team never had: modern computer models of how charged particles and magnetic fields behave when they run into a cloud of gas. He fed the 1997 measurements through those models, and the numbers told a story nobody had noticed at the time. During that flyby, Galileo's magnetometer had twitched. The magnetic field bent in a specific way. The plasma waves spiked, and the only clean explanation was that the spacecraft had flown straight through a plume of water vapor. A geyser, erupting off the surface of Europa, up to roughly 200 kilometers high, and Galileo had passed right through the top of it. Here's the thing: we didn't fly a mission to Europa, detect a plume, and celebrate. We flew through the spray of an alien ocean, packed up, went home, and didn't realize it for 2 decades. The evidence was sitting in a filing cabinet the whole time. And it wasn't alone. A few years earlier, the Hubble Space Telescope had caught faint hints of the same thing. Smudges of what looked like water vapor rising off Europa's edge. On their own, those hints were shaky, ghosts at the very limit of what the telescope could see. But now, you had 2 completely different instruments, decades apart, pointing at the same impossible idea. This moon is venting its insides into space. That matters more than it sounds. If Europa is spitting water off its surface, then you don't necessarily have to drill through miles of ice to sample its ocean. You could fly a spacecraft through the plume and catch the droplets. The ocean, in a sense, comes up to meet you. There's a catch, and we'll keep running into it tonight. The plumes are shy. They don't erupt on schedule. Sometimes you look, and there's nothing there. But every so often, this frozen little world reaches up and hands us a sample. And the first time it did, we weren't even paying attention. We flew through it, and we didn't know. For 20 years, Europa kept its own secret in our own data. Number 9. The magnetic fingerprint. Go back a little. Before anyone was chasing plumes, there was a much simpler and much harder question. Is there even an ocean down there at all? For a long time, that was a guess. A good guess, with some pretty pictures behind it. The cracked surface, the tangled ridges, the way Europa looks like a shattered eggshell someone tried to glue back together. But cracks in ice are not an ocean. You can't publish a paper that says it looks watery. You need proof. And the proof, when it came, arrived from the strangest possible direction. Not from seeing water. From magnetism. Here's the setup. Jupiter has a monstrous magnetic field, the biggest of any planet in the solar system. Europa orbits inside that field. And because Jupiter's magnetic field is tilted and the planet spins fast, from Europa's point of view, that field is constantly sweeping back and forth. Roughly every 11 hours, the field around Europa flips its orientation. Now here's the physics, and it's the same physics that runs the charger on your phone. If you take a conducting material, something electricity can move through, and you wave a changing magnetic field at it, the material fights back. It generates its own magnetic field in response, an induced field. In 2000, a scientist named Margaret Kyvelson and her colleagues went through Galileo's magnetometer data and found exactly that. Europa had its own magnetic field, and it was pointed the way an induced field should point, and it changed on the same 11-hour rhythm as Jupiter's sweeping field. The moon was responding. Something inside Europa was conducting electricity, wrapped in a global shell, right under the ice. And plain water ice doesn't do that. You need salt water. A global, salty, liquid ocean, conductive enough to answer Jupiter every time the field swept past. The perturbation was strong. The induced field was tweaking the local magnetic environment by up to 20%. This was not a whisper. This was the moon shouting back. Sit with how weird the method is. We did not drill. We did not see a single drop of liquid water. We proved that an entire ocean exists. An ocean that might hold more water than every sea on Earth. By watching how a moon bends a magnetic field it happens to be swimming through. It's like proving there's a fish in a murky pond by watching the ripples, and being so sure of the ripples that you'd bet your career on the fish. That 2000 result is the foundation under everything else tonight. Every plume, every salt patch, every hopeful chemical, all of it rests on the fact that in the year 2000, a magnetometer turned a guess into a near certainty. The ocean is real. Now the only question left was what's in it. Number 8. The double ridges. If you look at pictures of Europa, one feature shows up more than any other. Long double ridges. 2 parallel walls of ice running across the surface for hundreds of kilometers, with a shallow trough down the middle, like someone dragged an enormous fork across the whole moon. They're everywhere. They're the single most common thing on Europa's face. And for a long time, nobody could agree on how they form. Then, in 2022, a team at Stanford, led by a graduate student named Riley Kohlberg, cracked it, and they cracked it using ice right here on Earth, Greenland specifically. Because it turns out Greenland has a double ridge too. A little one, tiny compared to Europa's, but the same shape. 2 peaks, a dip between them, and the Stanford team had something priceless. Years of ice penetrating radar data from NASA flights over Greenland, collected between 2015 and 2017, so they could see inside the ice and watch how the Greenland Ridge formed. Here's what happened there. Water from the surface drained down into the ice and got trapped in a shallow pocket. Then it started to refreeze. And when water freezes, it expands. That expanding, pressurized pocket of freezing water pushed up on the ice above it and cracked it into 2 peaks, a double ridge, built from the inside by a pocket of liquid water sitting near the surface. Now line that up with Europa. Same shape, just enormous. If Europa's double ridges form the same way, and the match is very good, then all across that moon, there are pockets of liquid water sitting shallow, just under the crust, refreezing and cracking the surface into those twin walls. And that changes the whole picture. Up to this point, the story of Europa was, there's an ocean, but it's buried under maybe 15 or 20 kilometers of solid ice. Out of reach. A vault. But if double ridges mean shallow water, and double ridges are everywhere, then liquid water isn't just at the bottom. It's threaded all through the shell, close to the top, all over the moon. One of the senior scientists on the study, Dustin Schroeder, put it plainly. If there are pockets of water in the shell, close to the surface, where interesting chemistry from space can reach them, then life has a shot. The ice stops being a lid. The ice becomes a place to live. That's the quiet power of this one. We didn't need a new spacecraft to figure it out. We needed to look at the most ordinary feature on Europa, and a scrappy little ridge in Greenland, and realize they were telling the same story. The most common thing on that moon might be a sign that water is everywhere, just beneath our feet. Number 7. Sea salt on the ice. There's a region on Europa called Terra Regio. It's a young, chaotic patch of terrain, all broken and jumbled, and it has a color, a yellowish tint, standing out against the blue-white ice around it. For years, that yellow was a mystery. What is it? What's staining the ice? In 2019, two scientists at Caltech, Samantha Trumbo and Michael Brown, answered it. And the answer was almost funny in how ordinary it was. The yellow is table salt, sodium chloride, the same thing sitting in the shaker on your kitchen table. Here's how they nailed it. They used Hubble to look at the light coming off Terra Regio, and they found a very specific dip in the spectrum, right around 450 nanometers, in the blue part of visible light. On its own, fresh table salt doesn't produce that dip. But if you take table salt and blast it with radiation, exactly what Jupiter's brutal radiation does to Europa's surface, it turns yellow, and it produces that exact absorption at that exact wavelength. Match. The yellow on Europa is irradiated sea salt. Now, why does a pinch of salt rewrite everything? Because of where it probably came from. Terra Regio is young, chaotic terrain, the kind of place where ocean material may be pushing up to the surface. So that salt is likely a sample of the ocean below. And for decades, the models had assumed Europa's ocean would be bitter with magnesium sulfate. Epsom salt. The stuff you soak sore feet in. A chemistry that would make Europa's sea genuinely alien. Instead, they found sodium chloride, the exact salt that makes Earth's oceans taste like Earth's oceans. In one measurement, an alien sea went from weird foreign brine to something that would taste, at least in that one respect, unsettlingly like home. And there's a bonus buried in this. Trumbo pointed out that sodium chloride could be a sign the ocean floor is hydrothermally active, that there's hot rock and water reacting down there, cooking up this particular chemistry. Hold on to that thought. It's going to come back near the end of tonight, and it's going to matter a lot. For now, just sit with the strangeness of it. We looked at a yellow smudge on a frozen moon 600 million kilometers away, and we recognized the color of our own oceans staring back. Number 6. Rocket fuel for life. Let's talk about energy, because water is nice and salt is nice, but life doesn't run on water and salt. Life runs on chemistry that can release energy. Life needs a fuel, and it needs something to burn the fuel with. And this is where Europa does something genuinely interesting. Over those same warm, chaotic terrains, Terra Regio again, and a neighbor called Pallas Regio, telescopes have found hydrogen peroxide. Now you know hydrogen peroxide as the stuff in the brown bottle that fizzes on a cut. Chemically, it's water with one extra oxygen atom bolted on, and that extra atom makes it eager, reactive. It wants to give that oxygen away. The early detection of peroxide in Europa's chaos regions came around 2019, from work connected to scientists like Kevin Hand. Then the James Webb Space Telescope, with its far sharper eyes, mapped it in detail. And Webb found something odd. The peroxide isn't spread evenly. It clusters. It tracks almost exactly with where carbon dioxide sits, concentrated in those warm chaos terrains at the moon's mid-latitudes. In the warmer regions, there was more than twice as much peroxide as in the cold polar ice, which is backwards from what pure ice in a lab does. Something about the chemistry of those specific regions is cooking up extra peroxide. Here's why anyone cares. When hydrogen peroxide breaks down, it releases oxygen. And oxygen is an oxidant, the burn side of the equation. If you could deliver that oxidant down into the ocean and mix it with the right fuel, you'd have the chemical engine that life uses to power itself. But here's the tension, and it's the recurring heartbreak of Europa. The oxidant is on top. It's being manufactured at the surface, by radiation, in the ice. The fuel, the hydrogen, the organics, the stuff coming up from the seafloor, that's at the bottom. And between them sits kilometers of ice. Europa might be a battery with its two terminals separated by a wall. All the ingredients are real. All the ingredients are there. The only question is whether the moon has a way to connect them. And that's not a hopeless question. Remember the shallow lakes we're about to talk about, and the plumes that carry material up. There may be a plumbing system, there may be a conveyor belt. Europa keeps assembling the pieces of a living world right in front of us. It just refuses to tell us whether it ever plugged them in. Number 5. Caught in the act. Back to the water leaving the moon, but this time caught live from the ground by human beings staring through a telescope on a mountain in Hawaii. In 2019, a team at NASA, led by Lucas Paganini, used the Keck Observatory, one of the biggest telescopes on Earth, to hunt for water vapor directly in Europa's thin atmosphere. Not old data reanalyzed, not a magnetic hint. The actual signature of water molecules, glowing faintly in infrared light, right now above the moon. And they found it. On one night, they caught it clearly. The fingerprint of water vapor over Europa's leading hemisphere. When they added up how much water it represented, the number was staggering. Around 2,360 kilograms of water leaving the moon every second. That's more than 2 metric tons a second. Enough water to fill an Olympic swimming pool in a matter of minutes. Now, doing this is harder than it sounds, and the reason is almost poetic. Earth's own atmosphere is full of water. So when you point a telescope up through our sky to look for water on another world, you're trying to see water. Through water. Paganini's team had to build careful mathematical models to strip out all of Earth's atmospheric water from the signal and isolate only the light that came from Europa, subtracting our own oceans of vapor to see someone else's. But here's the detail that stays with you. They observed on 17 different nights across 2016 and 2017. 17 nights. And they saw the water clearly on exactly one of them. One night out of 17. Which tells you something important and a little maddening about Europa. Whatever is venting up there, it's not steady. It's not an old faithful geyser you can set your watch by. It sputters. It goes quiet for long stretches, and then, briefly, it breathes. That's why plumes have been so hard to confirm. You can point the best instruments in the world at this moon, night after night, and most of the time it just sits there, frozen and silent, giving you nothing. And then, once, on the right night, it exhales 2 tons of ocean into space. And if you happen to be looking at that exact moment, you catch it in the act. A frozen moon, holding its breath for weeks, letting it out just long enough for us to see. Number 4. The oxygen problem. Now for the reality check. Because so far tonight the news has been good, and I'd be lying to you if I said every discovery pushed the needle toward life. Some of them push it back. This is one. Here's the hopeful version of the Europa story, the one people told for years. Jupiter's radiation constantly smashes into Europa's icy surface. That radiation splits water molecules apart into hydrogen and oxygen. The hydrogen, being light, mostly floats away. The oxygen gets left behind, building up, ready to be delivered down into the ocean to feed anything living there. In the most optimistic versions, Europa was an oxygen factory, cranking out breathable chemistry on a huge scale. The problem was, nobody had ever actually measured it. It was all estimates, and the estimates were wildly spread out, anywhere from a few kilograms of oxygen per second to over 1,000 kilograms per second. That's not a measurement. That's a shrug with error bars. So in September of 2022, NASA's Juno spacecraft, which was built to study Jupiter itself, swung close by Europa and flew through its thin atmosphere. On board was an instrument called JADE, and for the first time, it directly sampled the hydrogen and oxygen Europa was producing. First real measurement. No more guessing. The result, published in 2024 by a team led by Jamie Saleh at Princeton, came in at around 12 kilograms of oxygen per second. About 1,000 tons a day. Now, 1,000 tons a day sounds like a lot, and in human terms it is. But compared to the hopeful estimates, it sits near the low end. Europa is making oxygen, yes, but it's making less than a lot of scientists had hoped for. And then there's the second half of the problem, the one that never goes away. Making oxygen at the surface is only useful if the oxygen gets to the ocean, and we still do not know whether it does. That oxygen is sitting on top of the ice. The ocean is at the bottom. If there's no efficient way to carry the oxygen down through the shell, then it doesn't matter how much gets made. It never reaches the water where it could matter. I want to be fair here, because less oxygen is not the same as no life. Earth's own biosphere spent its first couple of billion years getting along just fine with almost no free oxygen at all. Life is more inventive than our assumptions. But this measurement did something useful and a little sobering. It took the wildest, most optimistic version of Europa off the table, and it replaced a hopeful guess with a hard number. And the hard number was smaller than the dream. That's what real science feels like. Sometimes the universe hands you a discovery that quietly makes the odds a little longer, and you write it down anyway. Number 3. Lakes inside the ice. Let's go back to that broken, jumbled terrain we keep mentioning. Chaos terrain. It's some of the strangest landscape on Europa. Regions where the surface looks like it was shattered into rafts of ice, floated around, tilted, and refrozen in place. Like a frozen lake that thawed just enough for the ice to break up and drift, and then locked solid again. For years, that look was a clue nobody could fully read. In 2011, a scientist named Brittany Schmidt, working with data from Galileo, put forward a model that explained it, and the explanation was remarkable. She argued that chaos terrain forms above pockets of liquid water trapped inside the ice shell itself, not the deep ocean. Shallow lakes, sitting perhaps 3 kilometers below the surface, sealed inside the ice. And these are not little puddles. Schmidt's team looked at one chaos region called Terra Macula and estimated the water lens beneath it might hold as much water as all of North America's Great Lakes combined. An entire Great Lakes worth of liquid water, hidden inside the crust of a moon, a few kilometers under the ice. Now, why does a trapped lake matter so much for the question of life? Because of what it connects. Remember, the whole tension we keep hitting. The good chemistry is on the surface. The ocean is at the bottom, and there's a wall of ice between them. A shallow lake is a doorway in that wall. Oxidants and organics, created up top by radiation, can work their way down into these lakes. The lakes churn and exchange with the deeper ice, and over time, with the ocean. Schmidt described the ice shell, because of this, as potentially the most habitable part of Europa, not the deep dark ocean, but the busy, chemistry-rich boundary zone up near the top. So picture the full machine now. Radiation on the surface makes the ingredients. Chaos terrain and shallow lakes pull those ingredients down. Plumes and vents may push ocean material up. It starts to look less like a sealed vault and more like a living, circulating system. A moon with a metabolism of its own, moving chemistry up and down through kilometers of ice. We haven't seen these lakes directly. They're inferred from the shape of the surface, from the way the ice sags and breaks. Confirming them is one of the jobs waiting for the spacecraft that's on its way. But if they're real, they solve the single biggest problem with Europa as a home for life. They connect the top to the bottom. They turn a frozen shell into plumbing. And a world with plumbing is a world where things can happen. Number 2, where water meets rock. Now we go all the way to the bottom, past the ice, past the shallow lakes, down through kilometers of dark water, to the floor of Europa's ocean. Because this is the place that could actually matter most. This is where, if life exists on Europa, it most likely lives. Start with the scale, because it's hard to hold in your head. Europa is smaller than our own moon, a little frozen ball you could tuck inside the Earth with room to spare. And yet the ocean under its ice is estimated to hold roughly twice as much liquid water as every ocean on Earth combined. Every sea, every trench, every drop on our entire planet. And Europa has about double that, sealed under the crust of a world smaller than the moon. It might be the largest ocean in the solar system, and it's completely hidden. And here's the part that turns water into a possibility for life. That ocean is very likely sitting directly on rock, a rocky seafloor in contact with all that water. And where you have hot rock touching water, you get chemistry. You get hydrothermal vents. We know exactly what that looks like, because we have it here at home. At the bottom of Earth's oceans, in total darkness, miles down where no sunlight has ever reached, there are hydrothermal vents, cracks in the seafloor where hot, mineral-rich water gushes out of the rock. And around those vents there is life, not scraps of life, entire ecosystems. Tube worms, crabs, bacteria, whole food webs, all of it running not on sunlight, but on the chemical energy pouring out of the rock. This is the discovery that reframes everything. For a long time, we assumed life needed sunlight, needed a warm planet at a comfortable distance from a star. Then we found thriving cities of life at the bottom of our own oceans that had never seen the sun and didn't care. Life, it turns out, mostly needs three things: liquid water, the right chemistry, and a source of energy. Sunlight is one way to get that energy. Hot rock is another. And Europa, potentially, has all three. Twice Earth's water, the right salts and oxidants we've been finding all night, and a rocky seafloor that could be venting energy into the dark. If Europa's ocean floor works anything like Earth's, then somewhere down there, in the cold and the black, could be exactly the kind of place life got started on our own world. Now, I promised you honesty tonight, so here's the counterweight. Newer research, coming out around 2025, raises the possibility that Europa's seafloor might be geologically quiet right now, that it may not have the vigorous active vents we'd need. The jury genuinely isn't in. Some models say the floor is alive with heat. Others say it may have gone cold and still. And the truth is, from 600 million kilometers away, staring at the outside of a frozen shell, we cannot yet tell which world we're looking at. But that's the whole point of everything we've talked about. That's why this next one exists. Because there is exactly one way to settle it. Number 1. Europa Clipper is on its way. Everything tonight has been us squinting from a distance. Old data, reanalyzed. Faint light, filtered through our own atmosphere. Clever models built on shattered ice and a ridge in Greenland. For 50 years, that's all we've had. Inference and imagination, and the stubborn refusal to look away from one frozen moon. That era is ending. Because on the 14th of October, 2024, a rocket lifted off from Florida, carrying the largest spacecraft NASA has ever built for another world. Its name is Europa Clipper. And right now, as you're listening to this, it is out there in the dark, falling across the solar system, headed for Jupiter. Let me give you a sense of this machine. With its solar panels unfolded, Europa Clipper stretches more than 30 meters across, about the length of a basketball court, gliding silently through space. It's built so big, partly because Jupiter's radiation is so vicious, and partly because it's carrying an entire scientific laboratory. 9 instruments, all working together on every single pass. Cameras, spectrometers to read the chemistry of the surface, instruments to taste the thin atmosphere and any plume it can catch, and most exciting of all, ice-penetrating radar, the same kind of technology that revealed the truth about those Greenland ridges, which will look down through Europa's crust to measure how thick the ice really is, and to search for those hidden shallow lakes. It's a long road, Clipper won't arrive at Jupiter until April of 2030. To get there, it's flying a winding path across almost 2 billion miles, borrowing a gravity boost from Mars in early 2025 and another from Earth in December of 2026, slingshotting its way outward. And once it arrives, it won't just orbit Europa. The radiation would kill it too fast. Instead, it will loop around Jupiter and dive past Europa again and again, roughly 49 close flybys, stealing a little more data each time. And here's the part that I think is the most human thing about the whole mission. Europa Clipper is not going there to find life. Read that again. It is not built to detect aliens. It's built to answer one question that comes before that one. Is Europa habitable? Does it truly have the water, the chemistry, and the energy that life would need? Clipper's job is to find out whether the question is even worth asking, and if the answer is yes, to help pick the spot where a future lander might one day set down and actually look. Think about what that means. We have not found life on Europa. We may never. But we have found so many reasons to wonder. The ocean proven by magnetism, the salt that tastes like our own seas, the peroxide, and the plumes, and the lakes trapped in the ice. That we built a machine the size of a basketball court and flung it across 2 billion miles of nothing, just to get close enough to ask honestly. That's the thing about looking up. Every generation before ours could only guess about the worlds out there. They could dream about oceans on other moons, but they could never go and check. We can. For the first time in the whole history of our species, there is a real spacecraft, right now, closing the distance to a real alien ocean, carrying the instruments to tell us whether we are as alone as we've always feared. We might be the generation that finds out. Not through faith, not through fiction, but through a patient machine falling through the dark, headed for a frozen moon that has been keeping its ocean secret since long before there was anyone here to wonder about it. And in a few short years, it's finally going to knock on the ice and listen for an answer. Thank you for watching and sticking till the end. We've got plenty more videos coming in the future. Hit that subscribe button so you don't miss them. See you in the next one.